Hello friends, welcome to IMESH webinar. Today we'll be discussing about multi-tenancy and RBAC with Istio. So this is quite fascinating topic for large enterprises. Somewhere, the journey starts for medium enterprises when they have near about 500 employees and more, and they want to practice this multi-tenant the practice of multi-tenancy and RBAC in their existing infrastructure. Now, that can be a little bit cumbersome when people are using Kubernetes cluster throughout, or maybe adopting Kubernetes throughout. In that case, the existing RBAC provided by Kubernetes cluster may not be adequate, and that's the reason why many companies are looking into Istio, which is a security and networking platform for Kubernetes and heterogeneous infrastructure. Today, after a certain request from some of our clients, we chose this topic. And with us, Ravi Verma, who is the CTO of IMESH, he'll be speaking about this topic. Bit of housekeeping rules. This webinar will be getting recorded. So we'll send you after this webinar is over. Quick information about us. IMESH is formed in 2023. We basically moved out of stealth mode. We have been kind of working on service mesh project and other Kubernetes projects. As of today, we have three offerings. Number one is we provide enterprise Istio support. If you are implementing Istio open source and you need certain service or support for enterprise-wide adoption, then we are there. The second offering is Envoy API Gateway, which is a new ingress controller plus API Gateway functionality, which is released by Envoy project. It is almost like a Istio control plane. The last one is AI-based observability platform, which is proprietary software of IMESH, which helps to aggregate data from various software, various CI/CD tools, and give information about logs, metrics, traces, and topology. So now, without further ado, I'll just I'll let Ravi speak on the topic. Hi, Ravi. Please carry forward the discussion.
Thank you, Dubrasri. Hello, everyone. Good morning, good afternoon, good evening. So without any further delay, let's get into the topic. Today's agenda is we will be going through background of infrastructure, like what all the Kubernetes setup and different types and all, little bit of on that one, not very deep. Then we'll be discussing about how to achieve multiple or multi-tenancy in a single cluster way. We have different ways. We'll be talking about that, but today in today's session, we'll be going demo with single cluster, multiple namespaces, multi-tenancy, how to achieve that. So RBAC and multi-tenancy with Istio we'll be seeing the demo. Then we'll be seeing how to control ingress traffic for multi-cloud apps, which are like running in multiple clusters, multiple places, how to control that, and where and all that multi-tenancy with Istio can help there. And then we'll be seeing two more configurations. Definitely we have others as well, but we'll be talking like two more types here in today's session. Configuring multiple Istio with multiple namespaces, that can be done. Then we'll be talking the seventh one, like 7th point is like configuring the multiple Istio for multiple clusters, like it will be having different control planes altogether. Okay. So let's get started with background of Kubernetes multi-tenancy. So what happens when organization is kind of growing and they need setup for their applications to be deployed and all. So we have certain criterias where we choose whether to go single cluster, whether to go multiple clusters. So all those things we need to consider, or the admins usually take those decisions based on certain criterias, whatever we have listed out here. Definitely it's not all, but yeah, few of the key points we need to consider when we choose like what to do the setup, like in which format do the setup and what are the things to be considered. So the first thing is application, single or multiple applications. So when we have single applications or multiple applications, if it is single application, we can go with a single cluster. Even we can go with the multi-cluster in case of high availability, disaster recovery, all those things can be done. But yeah, based on that, we usually take the decisions. Then it comes to the second point, deployment speed and frequency. So if multiple teams are working on a particular project, or maybe a particular multiple teams are working in a separate areas of a thing, and each team is having different frequency of speed and release. So, and if it is having only one area, so what will happen in that case? When a particular team releases something, it might get impact other things as well. So that's where we take a decision whether to go with multi-cluster, multiple namespaces, all those things. We'll be talking about that, how it impacts. So based on the speed and frequency, because each team will have their own speed, frequency changes, microservices. Based on that, they do the releases. So that's also one of the point to consider. Then comes to the architecture, whether the solution, whatever a particular admin has chosen or yet to choose, is multi-cloud, whether we need to go directly with the multi-cloud, or it is just migrating from VM on-prem to multi-cloud or cloud. So all those things, it might have hybrid kind of setup as well. So based on things, there are different rules, regulations, controls will be coming. Then we have environment. So suppose we have 3 different environments, dev, stage, prod, and each is controlled by a different team. So definitely we need a control, granular control, who controls what all the things can be performed by each team, so that other areas like developers would not be interfering with the stage or prod environments. So all those things, controlling and on all those things need to be done. Then we have teams, groups like developers, DevOps, different teams, what all the things a particular team can achieve. For example, developers should not be allowed or will not be allowed to perform any actions on prod things or stage things, right? So similarly, DevOps team, they control the staging part and all. As prod SREs control the prod thing, and DevOps should not be, or maybe they not be interfering, or they might not have write access. They might have read access and all. They can read still, but they cannot write and all those things. So these are different things. Similarly, like marketing, pre-sales, like what all the access we can give to each area. Then we have user applications, application developer, full stack developer, like what all the areas of the application which particular user is touching and what all the access he needs. Okay, so only we provide that particular access, not to a higher extent. So we go with a narrow approach. Okay, you whatever you need, only you'll be getting that one. So that's the kind of approach usually we take. Then we have budget, limited budget. So definitely if it is limited budget kind of thing or starting out project or startup and all, in those cases, what will happen? They usually will start with single cluster, and but still they want the functionality. So what happens in that case? They might deploy different applications in the single cluster, but still they need a multi-tenancy because they don't want to interfere. So in that case, the logical separations and all will be coming. We'll be discussing on that, how and all it happens. Then we have whether we want a simple control, like only one place to control everything, or we have security, topmost priority, or different behavior, like where and all we can control. Whether we want a hard isolation or we can go ahead with the soft isolations as well, because we are just starting out. All those things, considerations are done. Then we can have a geographic, like multiple locations, multiple teams are working. So they might have access to different clusters. So different clusters. So definitely we need to apply different rules or to basically control all those areas. Okay, so these are the some considerations usually we take when we go with multi-tenancy and all, like who can perform what. All those things need to be considered whenever we are talking about multi-tenancy. So multi-tenancy in single cluster. So we, as I was mentioning, we can go ahead with multi-tenancy with single cluster, because when we are starting out just and we have limited budget and not so complex design and all, we can start with multi-tenancy. Definitely it's not the like always the best solution, but yeah, because we can have if we have very regulated environment, if we want hard isolations and all for different environment, different teams, we cannot go ahead with the single cluster part. That's where we have a multi-tenancy in multiple clusters. where we control we have granular control, or even we have a hard control on what each user can perform. So today we'll be discussing about multi-tenancy in single cluster and where Istio can fit in and help. Okay, so this is a simple case, normal scenario, like a sample application we'll be discussing in multi-cluster. So sharing a cluster between multiple teams. So here what can happen? So suppose 3 different teams are working on one microservice, or 3 different groups of developers are working on different microservices like profile, transaction, account summary. And what happens? They releases their applications on their own pace. And if it is only a single cluster without any restrictions, there could be possibilities like one can interfere into the other area as well possible. So these are simple, like if nothing is there, it will look like this. How to control and all this will be talking. So what happens in that case if we have either multiple developers working in the same environment or multiple teams working on the same cluster? So what we can do, so we can have a logical separation where we have namespaces. It means one particular group of people only perform certain actions on a particular area. Like only, like suppose if you see here dev namespace and staging namespace, it means if developers are given access to dev namespace, they can perform all sort of required actions in their namespace, but they will not be allowed to perform any other action or any view or anything, or maybe perform write operations on the staging. So those kind of controls we can do to set up a first level of isolation and first level of multi-tenancy. Similarly, like ingress controller can be there in another namespace where network administrator can control that one, so that it is not messed up with developers if something is going wrong, and it still works with all other areas. So this is first level of multi-tenancy we can achieve with the namespaces. Okay, but by default, when we even create namespaces, all the namespace will have all the access to every other namespace as well. So by default, it is having no restrictions, nothing. So this is just logical separation. Like we tell verbally, okay, this is your confined area, you only work here, but anything go wrong at any point of time. So how to control that one? So that's where we apply the second level of thing, where we control, okay, what all the things each user can perform. Okay, so multi-tenancy at Kubernetes level, it can be controlled with Kubernetes RBAC role and role banding. So we provide a set of rules, okay, these things this user can perform, and we bind that particular role to a user with role banding. So it means this user can perform only these certain actions on particular area. Okay, so that way the first level of isolations can be achieved and first level of control can be achieved with RBAC. But this is not sufficient to achieve a more granular or more control or more different complex scenarios. We'll be discussing about that later. Okay, so now the second level comes. So first level we saw what all the things can be controlled with Kubernetes RBAC. That controls, like it restricts access to the API server, like which user perform what all the things on API server. So again, going back here, so if you can see, it can get list, watch, all those things it can perform this particular user. So the user is Ali. So Ali user can perform all those things in a particular namespace. So dev namespace only is allowed to perform all these actions. But these are related to API server. How about other things like which application can talk to which other applications? All those things can be controlled with network policy. So this is sample application, like we can control, okay, this particular IP addresses can talk to a particular, this we can see like these are set of IP addresses are allowed to talk to this particular IP address. Like suppose it's a DB application and only these are allowed. So we can see we can control a set of IP addresses. We can whitelist a set of IP addresses to access to a particular port and IP addresses. Okay. But here we can only control at the IP level. Like it is, as we are seeing, it's a network policy. So definitely we can control only at the IP level. We can like level 3, level 4 level. We cannot go ahead above that one. So how to control more? Like if you want to have control on application level control, we cannot be like, it is not possible to achieve only with this one. So definitely we need something extra to achieve at that level, more granular control of the access control. So in that case, we can see how Istio can help there. So what we saw so far in Kubernetes RBAC, it restricts access to API server access. Like if a particular user is allowed to perform only this, only he can perform these things on a particular namespace. He will not be allowed to access any other namespaces, but that is using RBAC of API server. Like it restricts only access to the API server. Now we had discussed, after that we discussed network policy. Network policy restricts communication based on the IP and port. Like one pod want to communicate to another pod, but we can restrict, okay, only this set of IP addresses can talk to this one. But there also we have challenges, as we know, like IP addresses change. So that's why we had given range. Okay, but so yeah, so like we have given a range and all. But what happens if it is if the particular range is sometimes running out, or the new applications are coming in and all, we might face challenges. Definitely based on that, like admin will be controlling that. But yeah, it controls only at the network level, IP and port. We do not have control even further. So the next thing, what all we can achieve, like how to control more granular control, and at the higher level, what all the things, like how to even dig one more level down and control other things as well. Like for example, restricting applications, accessing other application in other namespace. So we saw that can be done partially with network policy, but yeah, definitely we need to have the information about IP address and all. And definitely we need to have control on IP address, because like if it is misconfiguration and all it's happening, what can happen, another namespace can get IP address and it can access to that one. Okay, if that is only we are allowing through the IP address, definitely we have namespace, all those rules are there, but it is, yeah, little complex to achieve, and lot many things we need to consider before applying. So that's the thing. And how to apply organization level security at user permissions only at a single place, from the single place, and we will be able to control all those things. So these are the set of top 5 questions we need to answer, and we will be getting that answer to that one using Istio, like all the things. How to apply rules to define which service can talk to other service, how to maintain and upgrade roles and easily, like as I was saying, it can be controlled only from the one place. All the things from all the cluster, all the things can be controlled at single place. How to control REST operations on ports. So like I was mentioning, with network policy, we were restricting only IP and port, but how to go further up and discuss, okay, what if I want to control a particular pod to only perform GET actions? What if a particular pod I want to allow only to perform POST actions? All those things cannot be controlled so far with Kubernetes RBAC and network policy. So definitely we need something more. That's where Istio helps. It is having more control, more granular control it provides, and we can control even further. So now let's see how and all we can do. So these are different setups we'll be talking. So achieving multi-tenancy and RBAC with Istio. So now with the help of Istio, we can, whatever we were discussing, that RBAC and all those things, how to control. So here we can see namespace, that ingresses in namespace. Then we have a profile, like the second circle we are seeing, that's a dev namespace. The third one is staging. So we can have same application deployed in two different namespaces, where two different teams will be working, and each one will have only access to their own. Okay. So set up authorization policy to Kubernetes resources. So namespace pod level we can apply so that it controls, like it restricts the access to only particular namespace. It is not by default, I was mentioning, it is allowed to access everything, but we need to control that one in a controlled environment, because we have different team, and one team should not interfere anything in another team. Then we have options where we can define with respect to who user or services can perform what all actions on other services. apply policies to ingress, egress, and sidecar from one control plane. So only one place I was mentioning as earlier as well. From only one place we can control everything. So that's the beauty of Istio. So here a sample application authorization policy. Here we can see here. So namespace staging it is allowed, and what all the things it is allowed to access we can see here. So it is telling based on this rule we can see source means from this cluster is a cluster name, namespace default, service account sleep. So service account of default namespace allowed to access these actions basically. These operations it can perform. It can perform get on profile. Okay, this path we can have event path, and post operation can be performed with the transaction, this path. Okay, so if we have different microservices with these two paths, it means the profile microservice can be accessed, only get operations can be performed with this sleep deployment or application. Okay, and post operation can be performed on transactions. And this one, and further namespaces, like if it is having from the staging namespace, then it can perform all this action as well. So we can have either service account level restrictions, or we can have namespace level restrictions. All those things we can control. Okay, so let's go ahead and see one sample demo where we'll be deploying two different like similar application into sorry, two different namespaces, and we'll be trying to enable authorization policy, trying to apply authorization policy so to restrict the access. We'll be seeing that thing live. So let's go ahead. I'll show it. So I'll be deploying three microservices: account, dashboard, and profile. What happens usually that dashboard accesses these two microservices, account and profile. Okay, and we'll have a authorization policy where we'll see how to restrict that one. Okay, so let's go ahead and deploy. Okay, or I might have deployed it, but yeah, still I'll apply kubectl apply FNF dashboard deployment. Okay, to dev namespace. So I have dev namespace where I'll be deploying these things, and then I'll deploy that to another staging namespace as well. Okay, let it apply. Okay, let me see. kubectl get ns. Config get context. Okay, fine. So let's go ahead and create those namespaces. Okay, so I'll be deploying application to two different namespaces. Let's create two different namespace, and we'll deploy and try to restrict those access to two different namespaces. Okay, so let's go ahead and create kubectl create ns. Suppose I'm giving div ns1. Why I'm giving this ns1? I will talk about that. Like there could be possibilities, like we can have a applications or microservices running in two different namespaces, and they are still part of the same application, like complete application, but two different teams owns that particular microservice, like two different. So, and they want a different control for each of their microservices. So we can have like a single application, single development application is controlled by two different teams. So it can have reside in two different name or more namespaces, and each namespace can have their own rules to control that one. Similarly, we can have like two environments, like or two different teams, like development team and staging team, and they can perform like complete application is deployed into the staging, and complete application is deployed into the dev. So we'll talk about that as well. Okay, let me create another one. Fine. And I'll create one staging environment as well. Fine. Okay, let's go ahead and make Istio enabled. Okay, so for that we need to apply a label kubectl label ns dev ns1 with the label we need to apply. So it's the Istio injection. So this one we are making as soon as we deploy any application, it will get sidecar proxy in it automatically. We need not to inject this manually. So I'm doing that. Enabled. Okay, similarly I'll do for 2 as well. Okay, and then I'll do for stage. Fine. So today we'll be seeing I'll deploy one application to dev ns, and the same application will deploy to staging ns, and we'll try to cross communicate between, like we'll try to access from one to another one, like from one space to another namespace, and restrict those access. So let's go ahead. First I'll deploy the application into the development environment. Kubectl apply. Let's apply a dashboard into dev. Sorry, typo. Okay, now I'll deploy 2 other applications. So those are profile and account. Fine. Now I'll deploy 2 sleep applications from where we'll be trying to access these applications in another namespace. So I'll deploy 2 different sleep application in a staging environment, and from there we'll try to access these deployed applications. Okay, so ctl apply sleep deployment stage ns. Fine. Then we'll try to this one to showcase like 2 different applications. Still they are in same namespace, but still they will not be allowed. Both will not be allowed to talk. Like even we can have that level of control. Only one microservice is allowed, or entire namespace is allowed. All those things can be controlled, and what actions that particular application can perform, that also we can control. Okay, so let's see. So now we'll try to access the application. So kubectl get pods stays. Okay, so let's try to enter into this one and try to curl that application running into the dev. So kubectl exec. Okay, it's running in stage. So let me write stage ns. Let me try to get access to shell. Fine, 1 minute. Sorry, one hyphen got missed. Okay, I got the shell here. We'll try to go to another one as well. 1 minute. Why this guy is not going up? Let me shorten it. Okay. So I'll do again. I'll try to enter into the another pod running into the same namespace, and we'll try to see what all things are allowed. So by default, as I mentioned, it should be able to access, like both applications should be able to access applications running in another. Sorry, again, I made a mistake here. One that's got missed. Fine. So this one is running sleep 2. This one is running sleep 1. Okay. Yes, and then we have this one. Okay. It's fine. So let's try to first curl from here. Curl. Then we have dashboard application. I was mentioning dashboard application calls account microservice and profile microservice to get information, and then it forwards the or takes that response and prints it here. So curl will be giving the, as we are into another namespace, we need to specify namespace as well. So dashboard dot, we have dev, we deployed into dev ns1. Okay, we have this dashboard in endpoint, and we need to provide ID equal to anything, some 1 to 10 we can provide. So we can see we got a response from these two microservices. We can verify the pod. We can see here pod name. Let's verify that as well, which is running. So kubectl get pods dev ns1 we just deployed. So we can verify this one. So account is having, at the end we can check 2w and here ck. So we can verify we were getting it account 2w something and then ck something. So definitely we were getting the response from these two guys. Okay. And here we can see we have Istio enabled already. So 2 out of 2 running. Okay. Now the same thing let's do from the another cell which was running the second sleep application, and we see we should be able to get that information as well. Okay. Now what we'll do, we'll try to access or try to restrict the access to one of these applications first. Okay. Or first we'll try to restrict the namespace itself. By default it is allowed. First I'll restrict that it will not be allowed. Okay. And then only a particular namespace is allowed. So let's go ahead and do that one. Okay, let me deploy a particular one more application into the dev environment or another dev environment so that we can showcase that as well. So let's do kubectl fly-f sleep v1 dev ns2. Okay, so we have another application running. Let's go ahead and execute to that kubectl get pods -s and dev ns2. So it is having only one application running. From there, we'll also try to access the same application running in dev ns1. So it is kind of example of sample application running in two different applications, and they want to access like two different namespaces, like different teams are working on different namespaces to have more control. So but still they want to access or communicate with each other. Definitely it's a part of the larger application, so they need to discuss or they need to communicate with each other. So kubectl check dev ns2. Okay, then we have shell. Fine. Let's try to access the application from that. Fine. So we can see, perfect. We are able to access. Okay. Now we have time for our main thing, restrictions. So currently we saw we have three different namespaces, dev ns1 where the application is running, dev ns2 where we have another application which want to talk to the application into the dev ns1, and we have a staging environment where another two applications are running and we won't allow, or currently it is like able to access everything. So now we'll start restricting the things. Istio is having different levels or different controls or different uh, resources to control different areas, and based on the need what we want to achieve we control. So we can have virtual service, like we can apply controls at different levels. Virtual service, destination rule, sidecar, service entry, all those things can be applied in a multi to achieve multi-tenancy as well. Even gateways, all those things are there. So like who controls what, we define a proper segregation of the roles, and based on that who controls what, that can be achieved. Today we will be using one part of it, that is authorization policy. We'll be using that to control the behavior, which microservice is allowed to talk to which another microservice. So that's one of the thing, but Istio is having a lot other things as well. Today we'll be seeing only one part of it. Okay, so now let's go ahead and see how the policy will look like. Okay, so what I can do, let me restrict to first ns1. Okay, so if I apply this rule, what will happen? Only dev ns1 pods will be able to talk to this dashboard, will be able to, all others will not be allowed. That will see in action. Let's go ahead and apply. So kubectl -f. Okay. Those created. Now let's go ahead. This one is running into the another namespace. This one is running also. Okay. So we have not deployed slip account into the current namespace. So let's go ahead, because then only we'll be able to see whether we are able to still access from the application running within the same namespace or not, because we applied that rule. All others will not be allowed. So let's go ahead and see. See, we are getting RBAC access denied. Okay, so this one is running in stage NS, the first application. This one again, let's try the second application. Okay, access denied. Then we have the dev ns2 we deployed again. So here also, so we can see like all other namespaces, they're not allowed to access now, but still we had allowed same namespace access, like this one, from this one allowed, this namespace is allowed currently. Okay, but to verify that we need to deploy same application into the same namespace, which is dev ns1. So kubectl apply into dev ns1. Okay, okay, and now create another tab. Okay, kubectl get words. Now let's see. Ideally, we should be able to access the application from the same namespace because we had applied that rule. Otherwise, if you don't apply that rule, even that slip application will not be able to call this dashboard. So kubectl sec Okay. Now let's copy this one, curl command. And let's check. Sorry. Does, oh, sorry, my bad. This one we are not into. Here it is NS1 typo. Okay. Now let's try to access. Yes, perfect. Even we can remove this namespace and we should be still able to access because we are running from the same namespace. Okay. So let's try that. Yeah, perfect. It's working. So all others are not allowed. Now only the same namespace microservices are allowed. So what will go? We'll go one level up. We'll specify, okay, I don't want to allow all namespaces. Okay, only a particular service from a namespace is allowed. So suppose if I want to even include the another namespace, which was dev namespace 2, I can allow that because it's the same. The development team is working, but I want only a specific applications to access that. So that also will be talking and we'll see how to restrict that. So now I'll do, I am adding another namespace dev ns2. So now if I apply this one, so application in dev namespace 2 will be able to access. Okay. Fine. Takes some time. Now let's try to, yeah. It takes some time. Yeah. So we can see here. Now we are able to access the application from dev ns2 as well because we allowed that particular namespace. It means all applications running within those namespaces will now be able to access application running in namespace 1. Okay, but still these two guys which is running in stage environment will not be able to access. Still they'll be getting access denied. Okay, we can verify that. Now the third thing what we can do, okay, fine, namespaces level, I do now my requirement is I don't want to allow all the applications in a particular namespace. I only want to allow a particular application in a particular namespace. Only those applications should be allowed to access. Okay, so for that, let's do one more level of control. Okay, so I am doing that here. So suppose I want to allow only sleep version 1 application to talk to that to access that dashboard application. The second application will not be allowed to talk still. So let's apply and see whether it's working or not. So let's apply that again. Okay, all previous things again, it should work. Let's verify. So this is in the same namespace we are getting. This one is the dev namespace 2. We should be able to access. Okay, now these are namespaces, staging namespaces. So this is 2, version 2, sleep version 2. Still it should not be allowed. This one should be allowed. So let's see. Still this guy should get access tonight. Okay, but we allowed sleep 1 version 1 to access that one. Still it is in the staging name environment, but now it should be able to access. Perfect. Right, so we saw different ways to control. At what level we can control, this is that to only one thing we use today, that is authorization policy. But still we saw how many different ways we can control. We can control like what all the operations it can perform. So currently only get, we can add post and all, and we can have add path. Okay, so only this path is allowed. All those things can be controlled. So we can see like it is having what level of control and what all the things we can control, what powerful it is. So that's where Istio is very powerful. It can help achieve multi-tenancy in a very great manner. Okay, so now let's get back to our slide again. So we saw we deployed application into 3 different namespaces. We tried to control different ways or different actions of what microservice, which namespace can talk to which microservice, all those things we discussed. So now we saw today all those things were done into the single cluster, multiple namespaces. So we were trying to achieve multi-tenancy with multiple namespaces. Okay, we have different even we can have further different requirements. Like few organizations might ask, okay, even I want further isolation and I want a different environment to be running in a different clusters. That's also possible. We can have dev cluster, we can have staging cluster. In one cluster, like only developers are accessing that one. The another one is only staging, or prod is having all separate. Altogether, it will be definitely separate. Okay, but still those environments can be controlled, or those 2 separate clusters can be controlled with the same Istio control plane as well. So all those rules and all it can be controlled at one place. Okay, even like this is a kind of environment. So second thing is like even if we have multiple applications, as I was mentioning that also, like multiple applications running in a different clusters, even that can be controlled. Like there could be possibilities, hard isolation requirement. Okay, I want a particular namespace or particular microservice to be running on another cluster altogether, because we don't have either space to fit in or some other requirements. Based on that, we can have it can be running, or based on HA availability, all those things, based on the requirements, it can be running in altogether separate clusters. Okay, we have different rules for that. So based on that, we can configure. So even that can be controlled with this one at a single place. That can be done. So that is one of the way. The second way is, even if you want even further isolation, even we want to separate our namespaces, cluster, and we don't want to control a particular or Istio or only one single Istio to control everything. Even we can go further. So let's see for what all the things, best practices, what we'll do. Isolation is important for multi-cluster, multi-cloud applications. If we have requirement, then we can go with like multi-cloud with multiple applications running in the multi-cloud, and based on the geolocations, all those things, like a particular application is allowed or only meant for a particular geolocations, so that those will be deployed to a particular cluster which is near to that particular country and all. Okay, so that way we can control even high availability, different like active, passive, all those things we can maintain, so that if active goes down, this passive one can control, but still we should be able to control from one plane, one central place, that is Istio. Okay, that is one of the thing. So now if some comes, okay, now even I want a further control over what all the things can perform who. Okay, even but I don't want to control those things only at the central place, because there could be possibilities like, okay, one can mess up and it can kind of ruin everything. So the another one level up we can go. So in that case, as I was mentioning, the first setup, like we have one Istio control plane, but we have multi-cluster. Okay, so the single Istio control plane can control all those things. It's either multi-cloud application or it is multiple applications in a different environments. All those things can be controlled using a single control plane. Okay. Now the second thing is, if we want to even further control, we can install a single or like one Istio in a all different clusters. So it means a particular Istio is controlling only particular cluster. So they'll not be interfering with each other. It means we can have different admins for each and every cluster so that we get more control, but definitely it comes with the cost, all those things. So based on the organization requirement, we can have different setups. Okay. So what we discussed today, we saw 3 types of setup: single cluster, multi-tenancy. In single cluster, we achieve multi-tenancy with namespaces. Okay. Then we saw a second one in which we can have either multiple namespaces across multiple clusters, or we can have environment across multiple namespaces, and still single Istio is controlling that. Then we saw the third one. Third one is multiple Istio is controlling multiple multiple clusters. Okay, so we get even more control, but definitely it comes with the cost and complexity, because we need to, now we have 3 Istios and all those 3 need to be managed by either single or multiple team. So definitely based on the either we want simplicity or security. So all it's kind of trade-off we need to, and at the beginning of organization journey, what they need to decide is whether they want to start with single cluster, multiple clusters, or they want hard isolations based on the client requirement or based on their organization need. All those things are considered and based on the different setups are done. But yes, in all those scenarios, Istio helps manage multi-tenancy in a very inefficient way and very controlled and very powerful way. That's all for today's session. So if you have any question at any point of time, please feel free to contact us at contact@imesh.ai. Thank you. Have a good day.